Welcome back. Dale Myers with Student Advanced. Today we're going to be talking about multiplying complex numbers, and I promise you'll find it easy. You know how I know? Because you've done it before. It just wasn't with complex numbers. Let me take you back to late algebra, or maybe it was just early algebra 2 for you. Multiplying binomials. I'm willing to bet you that you remember how to do this on the right. The distributive property, where you said, I'm going to take this x and multiply it times everything on the other side. And then I'm going to take this 5 and I'm going to distribute that. FOIL, you remember that concept, first, outer, inner, last, all that other stuff, right? Well, let's do that. So we would do x times x would give us x squared. Then the x times 3 would give us negative 3x. And then we do the 5 times the x would be 5x. And then 5 times negative 3 would be negative 15. You've done that before. Now we would do what? Combine like terms. Okay, so I'm just going to make a note. I'm just write, I'll type it in. Actually, I'll type it in. I'll type it in right here as a note to now we're going to combine like terms and simplify. And so let's do that. Well, the only like terms that we have here, negative 3x and 5x. Well, negative 3 plus 5 is positive 2x. And then we just bring down minus 15 and then x squared. That's our answer. Well, as you're probably suspecting, this complex number is done the same way. And as a reminder, and we did a video and I can link to it if you need to see it, but a complex number is just a number that has a real part, like that 2 is a real number, or that 5 is a real number, plus some imaginary part, 3i, 3 times I, the imaginary number, or 2 times I, the imaginary number. So it has some real part. So this is some real plus imaginary number times real minus the imaginary number. But all you need to do is use the same rules. Just as earlier, we distributed, we're going to say, well, this 2 has to be multiplied by everything on the other side. 2 times 5 is 10. 2 times negative 2i becomes negative 4i. We just distributed the 2 to everything in the parentheses. Now we are going to distribute the 3i. That 3i now has to go to the 5. 3 times 5 is 15 times I. That is positive 15i. 3i times 5 is 15i. Now 3i times negative 2. Well, 3 times negative 2 is negative 6. I times I is I squared. I times I is I squared. Okay, let's combine like terms. The only like terms we appear to have is negative 4i and 15i. Negative 4 plus 15, that will give us positive 11i. And we're going to just bring down our 10 and bring down our 6i squared. All right, it's pretty simple. One last step. Let me remind you, what does I equal to? I is the square root of negative 1. So I squared then, hold on. I squared would be the square root of negative 1 squared, which is, of course, the square root of negative 1 times the square root of negative 1 is just negative 1. So I squared is really equal to negative 1. This is important. We're going to take that right here. Negative 6 times I squared is really negative 6 times negative 1. Well, negative times negative becomes positive 6. So now we bring down that 10 plus 11i, and I apologize, it's getting messy. And then the last thing, now we ask ourselves again, can we combine like terms? Sure. 10 plus 6 gives us our final answer, and I'll write it in red. I'll write it in red up the top right so it's easy to see. 10 plus 6 is, of course, 16 plus 11i. So again, we just simplified it, or we multiplied it just like we do all binomials. This real number is in effect like a binomial. And then we had to remember to simplify the i's, okay? Let's do another one. But we're going to use the conjugate. If you remember, the conjugate is sort of like the opposite of. And let's look at it very quickly. So if I gave you 2 plus 3i, the conjugate of 2 plus 3i is 2 minus 3i. We're going to follow our same rules. We are going to first, let's distribute that 2. 2 times 2 is going to give us 4. 2 times negative 3i, negative 6i. You guys are okay with that. Now let's distribute the 3i. 3i times 2 is 3 times 2 is 6. So this is positive 6i. And then 3i times negative 3i. 3 times 3 is 9. I times I is I squared. Now, the cool thing that you need to remember is we multiplied. So when multiplying conjugates that are like the opposite of each other, the some terms will cancel out. In this case, our imaginary terms will cancel out. You'll see. Negative 6i cancels positive 6i, leaving us with just 4 plus 9i squared. Remember, I told you something would cancel. But remember, I squared, we said was equal to -1. Remember on our last example, if I was equal to the square root of -1, I squared is -1. So we put that right here. 9 times I squared is 9 times -1, or -9. Bring down our 4. This is 4 minus 9, or 4 plus the -9. Our answer is -5. So this is how we multiply complex numbers. We actually distribute it just like we would any other binomial. We have to remember to keep up with our signs, as well as I squared. When I multiply I times I get I squared, and we have repeatedly stated that I squared equals -1. So make sure you're changing your signs as appropriately. And finally, remember, when multiplying conjugates, your I terms will normally cancel out. No, not normally, they will always cancel out. And if they don't cancel, you did something wrong. So I hope this has been helpful. This has been multiplying conjugates. Please, before you go, give me a thumbs up, subscribe if you haven't. Feel free to share it with someone. And while we're at it, we are steadily building to the site. Go over to studentadvance.com, look for some practice exercises. If you don't see them, feel free to send me an email and we'll make sure it's up. We'll get it up there soon. Again, Dale Myers, Student Advance. Take care.